So what was next after that?
Well, that was in the 90s. That was in the 80s, that period. So I think after that, I got involved with the friction stir welding and additive manufacturing facility at South Dakota. We met with the senators. Tom Daschle was from South Dakota, majority leader, and those are back in the days of earmarks, and so we capitalized on that. And Maury and I and Tom Daschle used to have breakfast together down at Alex Johnson Hotel in Rapid City when Tom was a junior senator. And so we had that connection. And Maury was gone by the 90s. He had moved on to Utah again, or Nevada, I guess it was. And but we met with Tom and the senators from Minnesota, and MTS put this together. Larson, I think it's Gary Larson, and we got a $7 million grant to get a friction stir welder and a laser additive manufacturing system, which they built there at Arden Hills. That was MTS's interest. And then we got into the 5-axis friction stir welding with Bill Arbogast as the director. And I worked with that for about 10 years. I said I'd help support, the work over there and advise students. So I put out a lot of theses, students and their theses, doing friction stir welding and additive manufacturing. Jim Sears was there, a TMS name that you know well. And he was a real benefit to have. Enjoyed working with him.
Now, they didn't call it additive manufacturing then, did they?
We used that term fairly early on, but direct laser deposition was the more likely term early on.
I heard about it when it was presented at TMS for the first time. It's just this weird idea. And I think it was more called 3D printing or something.
3D printing is the term in the last few years. I don't particularly care for the term because it just seems not to have much to do with metallurgy, but of course it does. But we spun off a company there in Rapid City. I don't want to take any particular credit for it, but we met with Rob Mudge, an alumnus of the school, who runs RPM, which stands for Robert P. Mudge. And Robert did hard facing of mining and power equipment there in Rapid City, has a very successful firm and a very useful and generous member of the community, I might add, and has hired quite a few of our graduates from ME and metallurgy and built really a very nice direct laser deposition or 3D printing facility there, and has substantial contracts, or has had over the years, with the military. But I don't have anything to do with that because it's all secret contracts and confidential contracts. And but he's been very successful at it.
And then you also did your share of service to the university.
Well, yes.
Your term as department chair.
I did. We had a rotating chair system after Maury left, and the whole university went to that system. Ken Hahn was chair, and then after Ken, I was chair for 6 years, and then John Keller, and now Michael West, and TMS members.
Right. Now, did you enjoy being department chair, or was it a drag on?
Well, it was a challenge. I like challenges. And after a few years of it, I had all the files I needed to run the thing pretty efficiently, and got thinking that I could do this. So to the extent that when we went to a dean system, I nearly became the dean, but there's 2 candidates at the end. But Jan Pazinski became the dean, and about a day after he was appointed, we both agreed what was he thinking and what was I thinking, and I won, because that's a pretty difficult job. It was a 40% dean position, but he did a good job as dean.
Well, and I was thinking, even as department chair, you don't have the time Do they reduce your teaching load? Is that an automatic thing so you can fit everything into your
teaching
time?
load.
And research?
And research, yeah, friction stir welding and those things.
So your 80 hours.
Friction stir welding, and that came in near the end of that period.
So your 80 hours is edging toward 100 hours?
Well, I don't mind work. I still go in every day.
Well, and you, obviously some of that came from your upbringing, some of it came from John Hager's influence.
Well, yes, but really, the reason I go into work every day, Saturday, Sunday included, Sunday, it's always afternoon. I go in at noon and come home at 6:30. I like what I do. I enjoy what I do.
Ultimately, that's, you hope.
I can't imagine not doing it. You know, people ask me what my hobby is. My hobby's my job, really, too. I mean, I just enjoy what I'm doing. I'm writing apps now, metallurgical engineering apps for iPhones, smartphones.
So you went through the whole period with card punch readers and...
I was before card punch readers. I was on the LPG 30 system in the basement of the metallurgy building at Colorado School of Mines as a freshman, and we had punch tape. And when we were done, we rolled up the tape, put a paper clip on it, put it in our shirt pocket.
And you learned slide rules?
Oh, I love slide rules.
I was just after that. So
I love slide rules. I still use my slide rule. I'll use my slide rule before I walk downstairs to get a calculator. But mostly I just calculate stuff in my head. I don't need a calculator.
But you saw through that whole revolution when I'm thinking of apps as a culmination of 40 years.
Oh, it's
50
amazing.
Years of...
It's amazing what the transition has been. You know, as I describe it to my students, we've gone from numbers are expensive to numbers are cheap.
Big data.
Yes.
You want to use it that way, but then what do you do with it?
Well, you need graphics.
Yeah.
I started writing graphic programs with the Apple system, Fortran Toolbox, the graphic system in the 90s, late 90s, for big heat transfer codes and so on. I wrote those kind of things. And it turned out, I thought that was going to be a lot of work. It turns out the graphics makes the program possible because you can see an error right away when you graph it. Whereas if you don't, you're looking through reams of numbers. You can't see anything. So you need the graphics now to analyze your work, diagnose it.
So how does the app language compare to programming in Fortran?
Well, the app language I'm using is MATLAB. And
same MATLAB that's been around for a number of years in the field.
It's the same MATLAB I resisted for a long time. I like MathCAD, which is a GUI interface, but then I had to teach MATLAB, and I taught numerical methods for the math department to the metallurgists and mechanical engineers for quite a few years because I like numerical methods. I'm a computer guy. So in the last couple of years, ME just wanted MATLAB used. And so I got immersed in that. And it turns out I'm writing love letters to MathWorks, telling them how much I love MATLAB. Anything you want to do, you can just do. It is fantastic.
No more infinite do loops.
There are still programming errors.
So one other part of your formative career besides school itself is you did have several internships, right, both before and while you were at school.
Yes, I should mention my first job as associated with engineering was with the United States Geologic Survey, Water Resources Division, Surface Water Branch. I still have the name correct. And a fellow by the name of Leon Wiard, W-I-A-R-D. His daughter was in my French class, and she asked me one day, in junior year of high school, do you know anyone who'd like a job? I guess it was sophomore year, in fact. And I said, what kind of job? And she described that her father was this engineer and worked for the government. I'm like, I'll take care of that for you. Don't ask anybody else. I'll go talk to him this afternoon. Well, I got this wonderful job, hydrologic field assistant. I was a GS1, GS2, 3, 4. I worked for them for 5 years after school and on summers, and went out in field trips. We measured surface water from streams and correlated to the gauges and checked all the records in the office. It was a wonderful, wonderful job, and I am so grateful to Mr. Leon Wired for that. And he took me to a civil engineering professional meeting one time there at the Frontier Hotel in Wyoming, in Cheyenne. And so he was doing what so many of us should do as mentoring young people, and I'm so grateful to him in that position. In my junior year in college, junior-senior transition, I worked for Kennecott. Rush Pedden was the director of the research center there at 1515 Mineral Square on the University of Utah campus. And I spent a fair amount of my time out at the Garfield smelter on the moly capture, or moly roaster, where we were working to capture rhenium using a Cottrell unit. And I used to monitor that, spend some of my time down in Copper Row, Converter Row. It was quite exciting. I enjoyed that greatly. And then my first job after I graduated, after my senior year, I was at Rocky Flats for DuPont at the Atomic Weapons Division. There were about 30 of us who had summer positions. Mine was one of 3 that had required Q clearance, so we had top secret clearance, and I worked in building 76 and 77. My office was in 76, and that was the building that caught fire a few years later and had that near disastrous incident there that caused the closure of Rocky Flats. And but I worked for a fellow named Jim McClure. He was, I believe, a graduate of Colorado School of Mines, and it was a very thrilling position. Of course, we couldn't talk about a thing we did, and still I don't, except in the generalist of terms, most general. But that was quite exciting work. And then I had several interns as a professor. I never took a sabbatical. I never arose. I just never planned for it. I guess I never thought I was going to stay that long, so I didn't want the 2-year obligation. And so in 76, I worked at Stanford Research Institute in Menlo Park with Dan Kubachati and Robin Jones on zircaloy stress corrosion cracking. It was the effect of iodine daughter product on zircaloy. And then in 86, I went down to Edmond, Oklahoma, at Oklahoma City suburb, and worked at the technical center, Kerr-McGee's technical center, with Bruce Palmer, and modeled their titanium burner to see if they would benefit from using plasma heating, torches for heating. And my model was quite an extensive model. I wrote 10,000 lines of code that summer. That's all I did. And it was kind of fun. It was generalized, basically a big Runga kata integrator to keep track of products, heat transfer, and composition. And then I've acted as a consultant for large heavy equipment manufacturer and carburization. I'm an auditor at Yucca Mountain for the containment vessel, alloy 22, and titanium drip shields, and that sort of thing. So there have probably been some others. Did some patent work on developing high conductivity alloys. Turns out magnesium.
Pretty wide variety.
Copper. Yeah, that was Glenn Stone and I did that. I would like to mention Glenn's name. Glenn was my right-hand buddy. He was a physmeter and I was an extractive, and between the two of us, we did some interesting things.
Covered the bases.
Yeah, we covered the bases. He was a real X-ray guy. And Glenn and I still associate. He's about 7 years older than I am, so he's long retired.
And what about Mintech?
Mintech was a company I started with Dan Sarda to do corrosion testing with geothermal work. We had written and managed, I managed a number of geothermal projects in South Dakota for direct applications of geothermal water. We have water that's about 168 degrees Fahrenheit out in the center part of the state. We were involved. I was the PI on a multi-million-dollar project at the Diamond Ring Ranch, east of Pierre, about 50 miles, or west of Pierre, and then the St. Mary's project and one at Phillips Schools. We were corrosion consultants and things at Edgemont. So we did a lot of corrosion work, and we'd fly around the U.S. and the state and do corrosion measurement system. We were out in Nevada and so on. We part of the DOD.
You were the co-pilot?
I was a co-pilot. I was the navigator. Dan had his Cherokee 6, and we did a lot of flying. We flew to Baltimore. We flew to San Diego. We flew to Phoenix, and we landed out in the prairie many, many times. I have a saying about the Diamond Ring Ranch airport, if you will. It's 2 ruts in the ground over a fence post that you'd line up on. You land once, and if you're lucky, you take off once. We were plowing weeds with an overhead wing one day when we landed out there, and that's the day I flew the photographer from the Rapid City Journal out there. I about squeezed his leg off when we were landing because we were cutting the weeds off with that overhead wing. So we were young. We did lots of interesting things.
Now, going back one last time to your career as a professor, you have a lot of students you're proud of.
I have so many students I'm proud of. As a matter of fact, I never really thought I'd be an educator. I always thought I'd just go make steel or something. I love hot liquid metal. But it turns out, after all these years, I am pretty much an educator and professor. And I've tried to count how many students I've taught, but it's hard because the same student takes the same course.
Right.
And then you have all the ME students, and then you taught the geological engineers, thermo, and so on. So it's difficult. I know I've taught thermodynamics 49 times, and it kind of bothers me. I'd like it to be 50. So I'm hoping I get one more chance to teach thermo to make it 50.
Get it right.
Yeah, to get it right. I'll get it right
probably
50th time, right? And so I've had so many students succeed, not because of me, but I've been a part of their lives, a little bit of their lives. And 2 TMS Presidents were my students, Rusty Gray and Ray Peterson. And the faculty at the School of Mines, Grant Crawford was one of my students, John Keller, Bill Cross. And I told Bharat Jasti, who headed up the bladesmithing recently, a chairman, he was my PhD student. I told him not to apply at our university because we wouldn't hire our own graduates. And then 2 weeks later, he said, everybody's in the department's asking me to apply. So I said, well, go ahead. Well, he had worked at AIME Center for a couple of years before that. But so he's certainly one of my students. And so, we have lots of wonderful students over the years, professors all over the country, and that took some of my courses. That's just been a wonderful engagement. And we have students all over the world.
Professors, but also people in industry.
Oh,
so
in industry, sure. Yeah. Oh, yeah. Yeah, absolutely. Very successful people. And now they're coming back wanting to make major donations. We always try to instill a culture of giving among our students. We try to treat them well and support them as much as we possibly could. And they are very generous to us as a department and school.
They realize that they needed help. They need help to get through.
Right.
Often financially.
Well, South Dakota's
hopefully a few years later, they'll have the money to
Right. South Dakota is not a rich state. A lot of the youth that come into our university are, about half of them are from South Dakota, and they come from farms and small towns, and they're hard workers, and they know what work is, and they're just delightful to work with.
So you also did some work with students on zone refining?
Right. Well, that's part of the deep underground lab work that we have done. The deep underground lab was established by the U.S. government and was selected as the old Homestake mine, and they've carved out a space there at the 4,850 level, 4,850 feet below surface, for low background purposes, so they can do high energy physics experiments and their detectors work better. Right, yeah. And so that's quite a going concern. It used to be called the Deep Underground Lab. Now it's called the SURF, the Stanford Underground Research Facility. And Denny Sanford is a very successful banker, Citibank, as I recall, who's made major donations to the cause and for healthcare in South Dakota and throughout the region. So we're very appreciative of his contributions. I think he's donated, something in the order of 50 or more million to just get that facility up and running and maintained. And so now it's in full-fledged operation. Part of that, the state and the regions support what they call research center work. And I was a co-PI on a proposal that was funded for $5 million that the School of Mines eventually became a subcontractor from the University of South Dakota on that, from the PI down there, Dong Min. We had a couple elements to that. Mostly my part was involving germanium zone refining and single crystal growth. And there was another element somewhat associated with it. There was also Eric Hoppe at Idaho National Labs worked with one of my students to develop ultra-high purity copper by electrodeposition for the fixturing of the experiments, the high-energy physics experiments. And the reason that all has to be ultra-pure is for background, very pure copper. And we produced it from electrodeposition. Purest copper in the world, it's called. And if you search that on the web, you'll find Anne-Marie Siriano's name and Eric Hoppe, and she was my student. She was my last PhD student, in fact. She's in Germany now. And she usually attends this meeting. I hope she's here. So, TMS people. And so we zone refined and developed technology for that, or tried to replicate technology. That was done by another TMS member out at Berkeley. We went out and visited him. He's a TMS fellow. I should certainly remember him.
Jim Evans?
No.
I think who else at Berkeley is a fellow?
We visited him. He was the first one back 30 years ago. Developed ultra high purity germanium. It's very complex. We're looking at purities of 10 to the 11th or so. Difference between donors and acceptors per cubic centimeter, and then growing single crystals and so on. So that occupied the last 5 years of my time as a full-time professor.
So we've been nudging around your involvement with TMS.
Oh, I remembered the name. Haller. I think it's Haller.
Okay, we say it goes back 30 years, so, right. Reading about your involvement with TMS, it sounds like your first real recognition of the society came about a little unusual way with your casting project, your aluminum casting of the emblem.
Well, when we were juniors in Colorado School of Mines, we cast a plaque for ASM, and we would shine that up as part of the initiation. And there was a contest who was the shiniest. I really learned how to shine aluminum by that. We were really competitive students at Colorado School of Mines. And so in those days, as I recall, it was a joint AIME ASM membership. And I think it was $5.
For the student chapter.
Student chapter, yeah. And so TMS was years later. I think by the time I was at South Dakota School of Mines, we had to make a selection between TMS and ISS and so on. And I, of course, picked TMS, and never regretted that. I love TMS.
So your dreams of going to Pittsburgh and making steel, you went in another direction.
Well, by the time I graduated PhD, mini mills were coming online, and steel industry was not an expansive. It was not expanding, to say the least. As a matter of fact, I tell my students that right now our production is about a third of what it was in the 60s in terms of raw production. It used to be something like 300 million tons, as I recall. Now it's around 100 million.
Yeah, and the total focus have changed. Mini mills didn't exist then.
Right.
And
right.
now Nucor is the biggest steel company, and that's all they do.
That's right.
So quite a lot of changes. So you joined TMS originally when you were at CSM?
Well, it was AIME, ASM, joint chapter.
Okay. Oh, so the student chapter then. But what was the first meeting you went to, actually?
First meeting.
Conference.
Well, the first conference was when I was in graduate school. I think it was 1960. The first time I left Denver was to go to a conference was 1970. Because my baby girl was just a few months old, and that was so sad to have to leave my baby girl and go to New York City, I believe it was. But there was a conference in Denver the year before, and so I presented papers there, and that was exciting. I gave a couple papers. I had a brand new suit from May DNF or some such place, and I still have the suit, but I can't fit in it.
It's shrunk over the years.
It shrunk, right.
Yeah, that's what happens. Now, was that a TMS meeting?
Yeah, well,
TMS SME, were they doing it jointly at that time?
I never paid too much attention to that. John Hager just always said, you're going here, you're going there, and, we practiced the papers forever. But I think 72 was when TMS came on. So that would have been after that. That would have been before TMS broke out. But I think
that's true. If it was AIME then they might have all been.
I think so.
Though the petroleum engineers were off in their
right. Well, we met with our whole building cleared out in even in the early 70s. Geologists and the mining and the met people were all at the same conferences, like in Las Vegas and so on. Yeah, for several years in the early 70s.
Yeah, in some ways you miss those days,
right?
But we're so big in the fields have fragmented into their own. Now, did John encourage you to get involved? I mean, other than presenting, but getting onto committees and that kind of thing?
John Hager was very instrumental in my involvement in TMS. On the physical chemistry committee, he was chair, as I recall, and he invited me to move up through the physical chemistry committee. I was the chair of that in the mid-70s. And that was a huge committee then. It was 100 people or so. And so, I mean, when I look back on that, I can hardly believe that I was doing that early in my career. But I was. And it was because of him.
Well, and that's one of the advantages of TMS. The wonderful things is you go into committee meeting and you're a junior engineer and you're sitting next to, the technical director for Alcoa or
That's right.
whatever, and you're communicating as colleagues, not as
right.
a superior to.
It's a very egalitarian society, and it's just affords such wonderful opportunities to young people and mid-career people alike.
You progressed after you've kind of finished committee work, so you were chair of physical chemistry, right? Was there a rank up there? Because I think that was before technical divisions, wasn't it?
I never paid much attention to the organization. I could never quite figure it out, to tell you the truth. It was always a little confusing to me, and that's why when I became a little involved at higher levels, I was always concerned about how well we communicate organization to the younger members.
Yeah, you don't want to get them so confused that you lose them.
It could be confusing. So all I would ever hear about those things was somebody would refer to such and such a committee up above us that was going to rule on our suggestion,
your proposal,
that sort of thing. Or, that I paid attention to that, but I was a little uncertain as to how it worked. I never saw a flow diagram, for example, or an organizational diagram. I suppose they existed, but I'm pretty keen on that.
But then somehow you ended up in the presidential rotation.
Well, I never aspired to be in presidential rotation, or I never particularly aspired to anything except serving. And I guess the best way to summarize it is whenever I was asked to do something, I was glad to do it. I had some ideas. I didn't hesitate expressing my ideas, but I have to tell you that I've been far more impressed with my colleagues' service than my own, and yours in particular.
Well, it's all I tell the younger ones. It's easy because you just say yes.
Yes, that's true.
If you don't learn how to say no, you'll probably end up as president.
That's true.
Well, as long as you have to be somewhat competent. I guess that helps, rather than just enthusiastic. But
well, we look for certain qualities. I mean, but it is an open process. Nobody's wiring the positions. But when we look for people to encourage, we look for people with qualities, and I would say the qualities. And I know you want to probably talk about qualities and advice to young people.
You can move into that.
And that's the same advice I give my students, and that is be constructive. If there's one thing you could say, just be constructive,
not negative.
Yeah, I mean, we don't need. I mean, we need analysis, but we don't need, critical hacking of ideas and arrogance and those kind of things. Those are just so destructive to progress. So, real hard analysis, and engineers love to analyze and talk, and we all appreciate correct analysis and good numbers and good figures. So we're not talking about fear of looking at the truth, but we're talking about being constructive and polite and engaging with our colleagues. And that's an environment in which, it's called teamwork. And it's an environment in which we can thrive and make some progress.
Right. Rather than being divisive and my way or the highway or.
Well, on that score, I always told the board when I chaired the meetings with the board is you are not here to impose your opinion on the society. We're here and interested in your opinions, but there's going to be a collective decision made here. And if it's not your opinion, if it doesn't match your opinion, please realize that it's the best decision made in a deliberate process to arrive at the best decision for TMS. You're not here to impose your will. You're here to do the best you can for the society and your colleagues. And so that's, and if you disagree with the opinion of the board, say, well, it wasn't my choice, but I at least understood that it was done deliberately so people can support the board's decisions. For heaven's sakes, we don't want backbiting after. And I have to say the board has been very good at that. And it's a very cohesive board, and and the organization is running very smoothly. And I think people appreciate those concepts of doing the best they can for the society.
And you also have the issue that each board member represents a certain constituency in the society, and it is your job to advocate for them.
That's right.
But the good of the society may mean you have to subsume that.
That's right. That's exactly right. It's a give and take. It's a compromise. And it's a decision to support the mission of TMS. And the mission of TMS is to serve the profession and the professionals in the society.
Right. And sometimes you think that we could do just as well if we forget all the papers and presentations and just have networking and the presidential suite and so on, because of all the, you mentioned meeting Wendell Dunn at one of these. And you mentioned that even though you don't necessarily need to come to TMS anymore as part of your retirement situation, you wouldn't miss it because you have all these friends and colleagues that you've known for probably 40 years, some of the...
That's true. My many friends here at TMS, and I certainly have my colleagues at South Dakota, and I enjoy visiting with them. But I have so many dear friends here at TMS that I just am so glad to see, and I see them here, and I am thinking about the days when I am fully retired, how much I would miss not seeing them. I just think I have to come to the meeting to see my friends.
Well, I don't think you're going to be fully retired. But as we kind of close up, if you're probably still, as you talk to students, recommending TMS or professional societies. And what are you telling them when they're trying to think of their career?
Well, I just promote TMS as the society. And I ask them regularly, are you a member of Material Advantage, for example? Because that's their entry point. We have 5 students down here now for the bladesmithing competition. And they drove all night to come down here. I tried to encourage them to get a room. I told them I'd pay for a room, but no, they just wanted to drive all night, 5 of them, and get down here 1,200 miles later, and they're here safely, thank goodness. That always concerns me. But I very much encourage students to be members of Material Advantage and be involved in TMS. And whenever I have been at a meeting with students, I make sure that we take them out to dinner while we're down here and shepherd them around a little bit. But of course, they're interested in their own things too, and so I encourage that. But
they're still interested in free food,
right?
And drink if they find the presidential suite, or
yes. Well, I try to ask the presidents if they would mind if I'd bring the students up to the presidential suite to meet people like you and other important people at leadership. I think it's an important part of their experience. And then when we get back home, I always have them report to the other students what their experience was.
Yeah,
feedback.
That's nice, and feedback to us, hopefully, if there's things that we could do better.
Yes.
So, really going overarching, you decided in 7th grade you wanted a PhD in metallurgy.
Third or 4th grade. And 8th grade, I decided it was metallurgy.
Do you regret it?
No.
Is it if you try to remember yourself 40 years ago or 50 years ago, is this kind of, I know you thought you'd end up at U.S. Steel or something and making...
Yeah, my other thoughts in youth about what I might do was I thought about medicine, psychiatry, physics. I was a good physics student. But when I look back and think about those choices, I mean, certainly medicine and those things, that I would not have enjoyed that. I am not cut out to do that. I could do it for a week, but I've been at this 50 years at South Dakota.
And you can't stop.
And I've been doing it 60-some years from, junior high school. I like what I do, and I'm still doing it. And I just, like I said earlier on, I just think every night, I think how fascinating it is to me that now I know the answers to so many things I wondered about in youth. And what's even more amazing is there's so much more to know, and we'll never know.
There's no end. You know what heat transfer coefficients mean.
And my colleagues are expanding, these areas so fast that there's no way you can keep up with all of it. But it's a thrilling place. It's just the whole idea of the philosophy of modeling and describing nature is something we haven't really talked about, but it's a great fascination to me, why it works and how it works.
And the fact that so many complicated phenomena we kind of understand.
Well, what amazes me is somebody like Gibbs could come along and see through this and describe what he did in in his publications in 1905. And the quote I like so much about Gibbs, and he's my hero, his picture's on my wall, is that when Maxwell died, Maxwell sort of translated most of Gibbs' work to the rest of us so we could understand it. When Maxwell died, the people at Princeton said there were only two people who understood Gibbs' work, and now Maxwell's dead. But, fortunately, he translated Gibbs' work enough for us that we could understand it. Einstein called Gibbs the best mathematician in the Western world, and he doesn't get enough credit. I don't think people know the name as much as I think they should.
So we've talked about this a little bit, but, you're officially retired, right? You're an emeritus professor. I don't get the impression you're lying out at the beach.
No.
If there are any beaches around Rapid City.
Very ancient ones.
That's true. With not a whole lot of water associated with it. So what is keeping you busy now? You mentioned you're still going in. You still have your office at...
Yeah, I work every day from about noon till 6:30, faithfully. And I'm primarily writing applications for iPhones, smartphones.
You're teaching one class.
And I'm teaching. I took up teaching junior design because I missed being with the students and visiting with them and pontificating a little, I must confess.
They're a captive audience.
Right. They seem to listen. They keep showing up. So
that's important.
I enjoy working with them very much.
And how many papers are you thinking of writing still?
Well, I've got a list of publications I need to submit. Many of them are half written or fully written in some cases, but for one reason or another, some little thing has to be fixed, and so those things accumulate over time. I've got about 20 papers. I just on different subjects, ranging from mercury, chlorine interaction, a kinetic paper, to Gibbs-Duhem, ternary integration methods, to you name it, corrosion papers, all kinds of things that I need to put out, should put out. And I got 7 or 8 of those published this last year, and working on some of the, related to some of the apps we're doing, predominance diagrams, 3D predominance diagrams.
And that's the first thing I think of when I think of John Hager's graduate thermo class, is learning predominance area diagrams, right? Metal, sulfur, oxygen.
Right.
But they were always two-dimensional.
Yes.
But the world is not two-dimensional.
No. So we're doing three-dimensional, metal, arsenic, sulfur, oxygen. Although the program code handles anything. I've spent 4 years writing that off and on, and pretty much on full-time. And it started as a VBA, and now it's a MATLAB. And it puts isobaric surfaces in and does 3D rotations. And it's a nice program. I'm just weeks from finishing up and getting it packaged.
We distracted you by bringing
Right.
you here.
Well, just this morning I got a request for one of my LM diagram apps, if they could use it in publication. I said, of course, more than willing to make those things available. And so whether, how those show up in final form, I don't know. Whether I think some portion of them will be free. And the problem is, of course, with MATLAB is if you have any fee whatsoever associated with it, you need another license, and I'm not sure I want to pay for that. So maybe I'll just make them all free and give them to TMS or something like that.
Now, before we finish up, you had mentioned you've been thinking of your mentors over the years, your teachers, and not always the most obvious. John Hager may be one big one, but
yes,
there's others.
Well, there are other names that should certainly be mentioned, and I just feel so grateful for my opportunities in life and for the people who have made my education possible. Of course, starting with my parents, but there were a couple of teachers in high school and junior high that were just sentinel teachers, and their names should be mentioned. There was Jennings King. Jennings King was a science teacher in junior high, and he was the most ebullient, positive man you could ever expect to hope to meet. And every day after school, students flocked to his classroom. He'd stay till 5 o'clock grading papers, and the students would stay in the science lab and look at things and be working on things. And he was such a jolly man. You talk about a constructive man. He lived to be 100. He was recognized nationally for his efforts as a junior high teacher. Wonderful man, Jennings King. And then in high school, my math teacher and chemistry teacher. Math teacher is Paul Zimmerman, and he's still living. He's at nearly 100. He comes to our reunions, and he taught us calculus. And then there was Will Yost, who was our chemistry teacher. He was a wonderful man. And then in college, of course, John Hager. And one of my other thermo teachers was a fellow by the name of Rickman, Professor Rickman. He taught basic engineering thermo, and I never saw anyone who could lecture as smoothly as that man. I used to think he must work every night figuring out how to do these lectures, and then I later on, when I lived in married student housing and go through the student union, I noticed he was always at the bowling alley. So he had thermo down.
That's his secret.
Yeah, Professor Rickman. But John Hager, I can't say enough positive things about him. He introduced me to TMS. He introduced me to so many things. And
being fastidious.
Taught me to write.
Yeah, it was painful at times.
It was very painful. I remember once I just about told him if he knew how he wanted it written, do it yourself. But I didn't. I thought I'd give him one more chance. And I have thanked him countless times since.
Well, he keeps saying that I can call him John now, and I say, yes, Dr. Hager.
I call him John, but at this point.
Haven't quite gotten there yet.
Right.
So, do you have any final words?
Well, I just am so pleased with TMS and so grateful for all the opportunities TMS has afforded me. And, it's a society where we volunteer our efforts, but we get more back than we give. I'm certain of that. And the friendships developed here have been lifelong friendships. And I am sometimes amazed. I am always amazed. I'm continually amazed that I was honored to serve the society as the president, and I just have benefited so much, and I'm so grateful to TMS and good friends like you, Tom. And thank you so much for your interview, and Michelle for arranging this. It's been a wonderful ride, and it's not over yet.
It's not over yet.
Yes, thank you.
Thank you very much.
My pleasure.